And for this AC generator, to test the system, actually you need to run the engine. So that's what takes 3-4 hours. So maintenance goes back and takes 3-4 hours. Now operation has options here, couple options. I mean, few options. Option number 1, take delay for next flight. Number 2, cancellation. Number 2, use spare aircraft. There are also some options, but we are not going to discuss about these options. Okay? Now, what do you think? And then we are getting now to the point, what is the basic subject to assess operational unavailability? Let me just put this, I think more operational unavailability is more appropriate. So what actually operation is asking from product operational/technical availability characteristics, or what is the basic subject to assess the product unavailability? And answer is product maintainability. Only maintainability can tell us that we need these 3-4 hours to fix left AC generator. Definitely, I put here in this yellow box, in this orange box, safety and reliability, and definitely list is not limited with these 3 items, but maintainability tells us that we need 3-4 hours. Okay? Now, the quick question, where is maintainability starts from? Same point. Design, testing, manufacturing, certification, and goes to the operation, which is experience. So let me put here design plus experience. Okay? Now let's move one step back and simplify our simplify this slide. Balances between airworthiness, safe operations, and operational availability. So what we are saying actually, let me put this way. We have left side, which is green zone, green side, which is airworthiness. We said that actually we have 2 conditions. Condition number 1, product is airworthy, or condition number 2, product is not airworthy. Let's say left AC generator is inoperative. What we have from orange side, from operational availability, product is operationally available, or condition number 2, product operationally unavailable to accomplish the mission. How these green and orange boxes are connected? Very simple. If product is airworthy, it means that product is operationally available. If product is not airworthy, it means that product operationally unavailable. What is the connection word here? I would say, I would use this word. Connection word is technical condition. Okay, so connection word here is product technical condition. Let me explain how it works. Okay, let's say aircraft lands 11:30 the night, and 12:50 aircraft is scheduled in the midnight. After midnight, 12:50 aircraft is scheduled for the next flight. So we have 1 hour 20 minutes to prepare aircraft. Okay, so mechanic does perfectly everything. Everything is, aircraft lands, no pilot report, no findings, nothing. Everything is okay. So mechanic comes 12, let's say 12:20, and then signs release to service. So based on information, based on available information, everything is okay. So we don't have any technical problem. Now aircraft is going to take off 12:50. We put here 12:50. Okay, and mechanic comes let's say 12:45 to control engine start from the ground. Okay, so mechanic tells pilot, okay, we can start engine number 2. Pilot starts engine number 2, connects AC generator. Then mechanic moves to the left side, and mechanic says, okay, everything is clear to start engine number 1. Pilot starts engine number 1 and then tries to connect AC generator, AC, but unfortunately, pilot fails to connect the AC generator. So left AC generator is inoperative. Now, 20 minutes ago, the mechanic signs the paper where it says that aircraft is airworthy based on available information. And 20 minutes later, left AC generator is inop. Question. How we accumulate, or how this 12, let's call it 1250 point, how this 1250 point is accumulated, how this 1250 point is built up, how this 1250 point was developed. I put here 4 segments, and then foundation, definitely, I call it S, which is sources. Foundations are the next. The sources are the next. Product design, manufacturing, aviation authorities, regulations, requirements, airline operations, maintenance, and even passenger services. Okay, what we need from these sources, what we need from these foundation items? Actually, we are looking for C is collection. So we're collecting next information. Product technical characteristics and product economical characteristics. I put here product technical economical data. Okay, so let's say we collected this data. What we are doing? We are processing. What type of information we need? We are looking for information about product quality characteristics, about product quantity characteristics, and aircraft economics. So in product quality groups, we have next items. Item number 1, recognize, identify failure. So we need to see this indication that left AC generator is inop, not the right, but left, because actually left AC generator is inoperative. Next, we need to fix it. We need to replace this left AC generator. Next, return to service. As we said, the replacing does mean that product is automatically airworthy. We need to test it, and we need to do a lot of different things. So return to service means that we restore product airworthiness. This is group 1. Group 2, product technical quantity. We need information about product failure rate. This AC generator failure rate. Let's say every 600 700 flight hours, which is reliability information, product reliability information, reliability characteristics. We need time. We said 3-4 hours to fix it. Resources, let's say we need 2 mechanics, one certified, one non-certified. And these 2 items we have from product maintainability characteristics. And last group, aircraft economics. How much does it cost, or price per flight hours, or dollar per flight hours, or euro per flight hours? Now, definitely, these groups are not limited with these 7 items, but I think this is the major contributors from technical availability perspective. Okay? And last segment is analyzing. We need to analyzing all this information. We need to answer the next questions. What, where, how often, how fast return to service cost? What? AC generator. Where? Left AC generator, not right. Left AC generator. How often? We said 600 flight hours. How fast? We said 3-4 hours. Return to service. Product is airworthy before we send it back to the operation. And cost. How much does it cost? Nowadays, cost has more and more impact on these items here. Okay? On these questions. You can say even technical condition, product technical condition. Again, the list is not limited with these 6 items. 6, right? 1, 2, 3, 4, 5, 6. Let's say we can add airport. Why airport? The airport is very interesting. This 3-4 hours is not, if this happens, if left AC generator failure happened at the base station, these 3-4 hours is not the same 3-4 hours if this would happen in transit airport. It's completely different 3-4 hours. They are not equal. Okay? And again, we can put here more items based on your business model. So that's how this 1250 point was accumulated. Okay? That's how this 1250 point was developed. Okay? Let's move to the next slide and put here some mathematical functions, since we said that we are going to calculate operational technical availability on system level. Let's see how all these contributors they are affecting on our product availability and product unavailability from mathematical perspective, from mathematical side. So I put here left side operational availability, right? Product availability equals function of safety. Safety is always number one. Safety is always first. Failure rate, failure identification, failure recognition, failure